Hey, what's up? It's your old pal, Mr. Cook, and we're working on the 6C group work. So this stuff focuses on the law of sines and law of cosines. So although you won't need to memorize the formulas for law of sines and law of cosines, you do need to know how to use them, okay? So I'm going to go through these using the formulas, and if you don't know how to use the formulas, please, for all that is good in the world, reach out to your teacher and ask for some help, because it's just the formulas are easy to use once you have practiced them a couple times. If you haven't practiced at all, if you're just kind of hoping that you'll figure it out or something on the fly, it's not going to work. So just make sure that you practice with some direction. Anyways, going through these problems is going to take just a couple minutes, honestly, because we're just looking for an individual side or an individual angle. The only time that we're going to have like a little bit of a discussion on top of that is like for number 5 and number 6, because those are going to be cases where we have the ambiguous case. All right, so if you've already watched the video for the X review, you already know the steps that I'm going to take for solving. If you haven't watched that video, check it out, because I go through this a little bit slower. This is strictly for those of us that have practiced this a good amount and just need some clarification on getting answers and methods for solving. Okay, with that said, let's go ahead and start this up. We need to have a calculator and make sure that it's in degree mode. So just check the mode, it should be in degree mode. Okay, and when you want to do law of sines, remember that you need a side and angle pairing that is across from one another. If you don't have that, chances are you either need to find some more information or use the law of sines or law of cosines. On this first one, for example, we're looking for AC, so that's the side X, and luckily we already have an angle and the side across from it. If we have that, we can use the law of sines to solve for this missing side length. So we set up the law of sines. The sine of one angle, 30, over its opposite side, 13, is going to be equal to the sine of another angle in the triangle, 88 degrees, over its opposite side, x. So now all you need to do is just cross multiply and solve it. When you do that, you end up with the following. X is going to be equal to 13 times the sine of 88 over its opposite angle, not opposite angle measurement, dang it, over just this angle measurement, the sine of 30. So when you type that into your calculator, you get your answer. So that's going to be 13 times the sine of 88 divided by the sine of 30. And you get your answer, 25.98. So x is about equal to 25.98. And that's rounding to 2 decimal places. So there's our side length. Next up, number 2. Well, we don't have any sides or angles that are across from each other, nor can we solve for these angles or the side just by using conventional triangle properties like Pythagorean theorem or the sum of the interior angles. So we're only left with, we're not allowed to use the law of sines, so we're going to be using the law of cosines instead. And it's really nice to do this because AC, the side length x, is exactly what we would solve for using the first formula of the law of sines, law of cosines, the one where we solve for a side length. It goes something like this. The side that we're looking for, let's call that x squared, is going to be equal to the sides around the angles squared and added together, so 20 squared plus 24 squared, minus 2 times each of those sides times the cosine of the angle that's between them, which in this case is 82 degrees. Now, I can type this whole thing into my calculator, so that's what I'm going to do, 20 squared plus 24 squared minus 2 times 20 times 24 times the cosine of the angle between them, which is 82 degrees. Then I hit enter, and that gives me my x squared value. So to get x by itself, I remember that I need to take the square root of this. So square root of that number gives me 29.02. So that's this missing side length here. For number 3, the side length BC, so that's going to be x over here. I have the angle that's across from it, but unfortunately, as of this moment, I don't have an angle that's across from the side length 11. I need B to be able to have that, so to use the law of sines. Luckily, I have these two angles, so I can solve for this angle by knowing the fact that all 3 of the angles in a triangle add up to 180. So if I take these 2 away from 180, the remainder is going to be that B value right there, that angle measurement for B. So I take 180, subtract away 126, and subtract away 34 in my calculator, and I get 20. So this is going to be a 20-degree angle. Now I have the angle that's across from the side, so that means I can use the law of sines to solve for x. So I do the sine of 20 degrees over its opposite side 11, and that's going to be equal to the sine of 126 degrees over its opposite side x. So now I just cross multiply to solve this, and I get the following. X is equal to 11 times the sine of 126 over its opposite, not opposite side, I keep saying that, over the sine of 20. So we just type that into our calculator, and we get our approximate answer for x. So x about equal to, let's see here, 11 times the sine of 126 divided by the sine of 20. And that gives us 26.02. So 26.02 is this side length. All right, so that's the first 3 problems in under 6 minutes. And just drink a little bit of water. I got a little bit of a cough right now, so that's pretty nice. Okay, there we go. All right, so now I'm going to get angle A. So angle A is right over here. And notice that I don't have any other angle measurements in here. In fact, no angle measurements. So that means that I cannot use the law of sines, and I have to use the law of cosines. So this is where the second formula comes in handy, because this formula is the same as this one. It's just solved for the theta measurement there, the angle measurement. And that's what I'm going to do. I'm going to solve for this angle A. So I do the cosine inverse of, and it's a big fraction, and it's going to be the 2 sides around the angle squared and added together, so it's 6 squared and 9 squared, minus the side across from it squared, all over 2 times each of the sides around the angle, so 6 and 9. So then just type it into your calculator like that, and you get your answer. All right, so let's see here. That's going to be cosine inverse, so second cosine, and then parentheses. Now I do the top part, 6 squared plus 9 squared minus 14 squared, parentheses, that's the numerator, divided by, and then parentheses for the denominator, 2 times 6 times 9. Type it in, and you get your answer, 137.01 degrees. There's our missing angle measurement using the law of cosines. For these next ones, we have to put the triangle together. So we're going to have vertices A, B, and C. So I'm going to draw those out here, A, B, C. Angle C is 50 degrees. And then AC is 30, AB is 29. So this is the ambiguous case when we have an angle, a side across from it, and a side right next to it. So this could be, a situation where it's just a single triangle, which is great. It could be a situation where this actually doesn't make a triangle, which would be even better because we don't have to solve for anything because it's not possible. And then there's also another case in which you'd have to solve for 2 different triangles. Actually, this is that case where you have to solve for 2 different triangles. So the reason that you have to do this is because of the fact that just like as a visual example, like your unit circle, the angles that go from 0 to 180 have repeated sine values because it's reflected over the y-axis here. So like, just as an example using your unit circle, if I had a 30-degree angle, that would give me a sine of 1/2. And then an angle measurement of 150 degrees would also give me a sine of 1/2. Since 30 and also 150 can both potentially be angle measurements inside of a triangle, because triangle angle measurements go from 0 to, not including 0, but going from 0 to 180 degrees and not including 180. Both of these angles are potential answers for a triangle. So in other words, you get like one acute and one obtuse triangle, so to speak. So really what you get is 2 triangles for the price of 1. So I get another triangle that has the exact same given information, ABC here. The angle C is 50 degrees, the side across 29, and the side right next to that is 30. So these 2 triangles are what I'm going to get from this, and they're going to have completely different angles and also sides that I get to solve for. So let's find the first part that you can actually solve for, which would be angle B. Now, angle B is what we're looking for, and it just so happens that's the only thing that we can solve for on this triangle. Because, using the law of sines here, the sine of 50 over its opposite side, 29, is equal to the sine of B, which is what we're looking for, over 30. So this angle B is what we're going to solve for using the conventional methods of law of sines. But this angle B on the second triangle that we have, so this is like triangle 1, this is triangle 2, On triangle 2, that angle measurement that we're going to get is going to be the supplement of this angle. So they're going to add up to 180. So that's how I find the two answers that I'm going to get for angle B in this case. This is a really weird one, isn't it? All right, but anyways, let's solve for B. So we cross multiply and we end up with the sine of B is equal to, and then it's going to be, let's see, 30 times the sine of 50 over 29. And then that's all calculator stuff right there. So 30 sine 50 over 29. So the sine of B is equal to this ratio. So to get B by itself, I do the sine inverse. So let's see what the angle B is going to be equal to. Looks like it's going to be equal to about 52.42 degrees. So that's one way to find this angle B. And then the obtuse angle that we need to find. So this obtuse angle is going to be supplementary. So this is the 52.42. To find this angle, I need to find its supplement. So the other angle is going to be 180 minus that 52.42. So let's see what our angle measurement is going to be. 180 minus 52.42. And we get, oops, what did I write down? Oh, I put a negative symbol there on accident. 180 minus 52.42. That's why. So that's supposed to be 127.58 degrees. So that's our other angle B measurement. So there are two angle B's here. Those are both of them. Next, we're going to do number 6. And oh no, if you look at it and set it up, it's another ambiguous case problem. Angle C is 91 degrees. AC is 7. AB is 5. But this is actually the good one because we have an obtuse angle. And if the side across is bigger than the side next to it, it's actually not possible to do this triangle. The reason that that's the case is because if I have an obtuse angle here and a side length here and then a side that's bigger here, it implies that this angle has to be larger than this angle. And that's actually not possible because if I had a 91 and then something bigger than 91, so let's even say it's 91 again, that gives me 182 degrees. And we all know that a triangle, the interior angles, the sum of the interior angles is always going to be 180 degrees. So it's not possible to make that triangle. That's the whole reason behind it. Okay, so that's this first group of problems, and I think I'm going to call it, that's it for this video, and then we'll move on to the solving the triangle stuff.